All, welcome back to this video. We are continuing our journey on Docker, and our ship has definitely sailed into deep waters now, and we want to continue understanding more details on the Docker. So in this specific video we are going to talk about two things. So I have been using a lot of jargons, image, container, and sometimes if you are totally new to the Docker, if you haven't been exposed, then this can be confusing terms. I want to take this, I want to use this video to make sure that you understand what does image and what does container mean, so that there is no confusion. So that's one thing. Then I'm going to introduce you to a Docker lifecycle. So Docker lifecycle, whenever you create a container, it goes through certain steps. So through this video we'll understand that and what is the importance of that Docker cycle as well. With that, let's get started. So we want to discuss first image versus container. Are they same? Are they different? Can we use them alternatively? No. So the answer is no. So image and container both are different things. Okay. So one analogy that I have prepared is this, right? So if you have worked on Java or some statically typed language, what we do is, for example, in case of Java, what we do, we have a Java program. Okay, so on your left you can see the kind of a diagram that I have shown. We have a class sample which is a Java class. Okay, it is fed to the Java compiler called Javac. Once you feed this class file to the Java compiler, the output is a class file which is nothing but a byte code. Okay, and this class file is then fed to the JVM, or it is run on the JVM to create the object, and then you can create, let's say, as many objects that you want from that class. Okay, and you need not restrict yourself to just creating a one class. As long as you have this sample class blueprint, you can choose to create many classes, many objects from that blueprint called sample class. On the similar terms, you have a Docker file. Now I haven't shown you a Docker file. What does a Docker file looks like? Let me quickly show you and then we'll come back. Okay, so let me quickly show you. So this is a sample Docker file. You can choose to ignore this syntax right now. This Docker file is used to create your own image. Right now we have been using a node image. We have been using, so other day we use sample run, we use the hello world image, and there are many images that we saw on the dockerhub.com, right, where different companies publishes their image, right. Similarly, if I want to publish my own image with everything packaged, my application and all the libraries, I use a Docker file. So consider this Docker file as a class. So the sample class, similar to this Docker file is, where it has instructions and where we tell how to package this entire image or a container, right. So you have this Docker file which is fed to a Docker build tool. Let me tell you about this. So if you run Docker, you will see a build command here, right. If you see, so there are this build commands which is used for building, here it is, right here, build an image from a Docker file. Okay, so you have an image here. Okay, and then this Docker build is used to build an image from the Docker file. Okay, so Docker file is fed to the Docker build tool. What it outputs is a Docker image. Okay, now let me quickly show you. If I want to know how many images I have, how do I do this? So if I run docker or -- help, I can see I have this command images, right. This is the command that I have which lists the images. Okay, so I'll do docker images. It will tell me all the images that I have on my machine. So now I am seeing I have getting started as one of the image name. Okay, so getting started is the image which got created after a Docker file was fed to a Docker build tool. Okay, and this is, you can consider this just like a class file. This is similar to a class file. Okay, it is not a live object, or it's okay. And once this Docker image is the Docker image is then run using docker run, and there are other alternative commands also. This is a shortcut. When you feed this Docker image to a docker run command, then you can create containers, and you can create as many containers as you want. So this is the analogy between a Java program and a Docker process overall. So you have a class Java sample class file, which is same as a Docker file. You feed that class file to a Java compiler, and out comes the bytecode class file. Similar to that, we feed Docker file to a Docker build tool, out comes a Docker image, and then class file is fed to the JVM, and you can create as many objects, live objects as you want. Similarly, from Docker image, once it is fed to a docker run command, you can create multiple containers for the same. That's the analogy I wanted you to understand. What is the difference between image and a Docker file? Image, consider image like image is not a blueprint. Image is basically a bytecode, okay, where the entire thing is packaged, and a Docker file is basically a set of instructions that what needs to be packaged under that image. An image is something which is ready to run on your Docker daemon. I hope that understands and helps you and clears if you had any doubt regarding what is Docker image and Docker container. Let's move ahead. Excuse me. Next, I want to talk about Docker container lifecycle. So whenever we create any Docker container from a Docker image, it moves through a certain life cycle, and it is important to understand that, so that we know, and it helps you in debugging, it helps you in development. Okay, let's move to the next slide. Now this is the main life cycle. It has 5 milestones. Okay, so when you have a Docker image available, you can choose to create a container using a create command. So if I go back now to a terminal, docker ---- help, you can see a create command. What it says, create a new container. So it creates a new container, and this new container, once it is created, it can be then started using a start command, and that's when it starts running. So it comes to life only after that created container is started, or there is a shortcut. You can straight away do docker run and then the image name, and it will bring that container to running state. So create and start is a 2-step process, but run does the same job. Run kind of is a shortcut which does the 2 things. It creates the container, starts the container. Once you are in running state, it can be paused and unpaused. So when you pause the container, it becomes, so it is not available to the service then, meaning let's say you are running a certain service on a container, right, a kind of a server. Once you bring that to a pause state, then it will not serve any request. And why do you want to do that? It could be for, let's say, maintenance purposes, it could be for some debugging purposes. And how do you move this paused container to unpaused state? Is by using a command called unpause. I don't know, unpause is actually unpause is actually English word. I think it would be resume, but yeah, anyway, pause and unpause make sense in this context. Once you are in running state, then the running container can be stopped using a stop command, and stop container can then be brought to a life using a start command. Okay, so from created you can run a start command to bring to a running state. Also from stop you can bring back your container to a live state using a start command. And from stop state, this container then can be completely removed from your image or a Docker daemon. Similarly, a created container can also be removed from the Docker daemon. So this is the high levels. These are the high level steps, or in fact these are all the states that happens when a Docker container runs. What we are going to do is we will go through a quick demo on this. So if I want to know what images I have on my machine, so I will do docker --help, and then I have this images command which lists the images. So let me do docker images. Thankfully I have this getting started as the image here. What I'm going to do is I'm going to run docker create getting started. Now this gave me a SHA-1, and if I do docker ps, it will not show anything because it is not it. Docker ps, if you recall from the previous videos, docker ps only shows the running containers. But if I want to see all the containers in all the different states, I can do -a. So you can see, I think I had started this container some time back, but this is another container that we had started around 20 seconds back, okay, which is in created state. This was in exited state. Now what I'm going to do is, once this is in created state, as you can see it is in created state, I can use a start command to bring this into running state. Now there are two ways I can do this. I can use the container ID, or I can use this name which is given to this container. So when I created this container, I could have given a name as well to the container. For example, I think let's use this name for now, or container ID. Let's use this name for now to continue further. So I can do now docker start interesting Clark. Okay, I have run this. Let's do docker ps -a. Now you can see this has been up for 4 seconds now. This container just started interesting Clark. Now this is listening on port 3000, and this container is in now running state. This is where it is. Okay, now what I'll do is, the same thing can be done using run command. I think we have seen this already when we ran a hello world, or let's do that one more time. So when we do docker run hello world, but this will exit actually immediately after running because it's not meant for what we are trying to show here. Let's skip that, and then we'll try docker run on getting started after some time. Now I am in running state. I can do docker pause an interesting Clark, and let me check the status now. Okay, so it says that this current status is pause right now. This container is not running, but it is in a pause state. How do I bring this from pause to resume state? I will use docker unpause, and if I check the status now, you can see this is back to life now. It is up and is running. Now let's move this container to a stop state. So I can do docker stop an interesting Clark, and if I do docker ps -a, I can see this container has exited now. Okay, it was running earlier, now it exited 4 seconds ago. From exited, I can go back to running state by using the start command. So if I do docker start interesting Clark, if I do docker ps -a, I can check that this is up from 2 seconds because it was exited. Now it started again, so it has been up for last 2 seconds now. Now let me bring that to let me stop this container. So I stop this container now, docker ps -a, so I can see this container now. Okay, now I want to do this, I want to delete this, right? So what I'll do is, now you can see the docker rm command, and if you remember, we talked about this in some previous videos. So if you want to remove a container, the rm is the command, remove one or more container. And if I want to remove an image, I can do rmi here, docker rmi. Okay, now we want to remove an container now. So docker ps -a, if I do docker rm and then copy this name. Okay, so now if I do docker ps -a, so you can look at the difference, right? So this container was in existed state and it was getting listed under docker ps -a. Now that we removed this using the docker rm command, it is no longer present here, and this was the old one. You can skip this one, you can ignore this one. And similarly, from stop state, also from created state, the container can be removed. So this is the overall life cycle of a container. I hope things are clear. And in the next section, we are going to talk about Dockerfile in detail, like how to create your own containers. I will help you understand what is Dockerfile, what are the different syntax, and we will build step by step. We are going to start very slow, gain the confidence, and build on that foundation that we are building in the next few videos. I hope you like this. Thank you everyone.